basically it's got every single little bit in a very standard form. Okay, so what we got here, we're making ethanol. There's your reaction. It's giving us a delta H of minus 45. If it's negative, you might remember that means that it's exothermic. Think about your graphs again. So if it goes down, that's your exothermic one. So if it's exo that way, it's endo that way. First job, define equilibrium, 3 marks. This should be easy peasy. Right, you've just got to learn this stuff. So forward reaction going at the same rate as the reverse reaction. So that's one bit thing. Right. Second point that you need is the fact that therefore the concentration of reactants and products is unchanged. And the final thing is this will only ever occur if it is in a closed system. So that's absolutely bog standard stuff. Closed system, forward reaction, same rate as reverse reaction. Do not be tempted to say that the amount of reactants and products is the same. That is not true. It's about the fact they're going at the same rate. Concentration remains unchanged, but the concentrations could be different. It just remains unchanged and in a closed system. Right, how would increasing the temperature affect the yield? Well, we've just decided that the forward reaction is exo and the reverse is endo. So if you increase the temperature, it tries to do the opposite, so it goes in the endothermic direction. So the amount of your ethanol will go down. All right, so the yield will decrease. Why? Because the forward reaction is exo or the reverse is endo. Either of those are acceptable in terms of the mark scheme. So forward reaction is exothermic. I hope you're enjoying the hoovering and piano tuning in the background. Right, so there you go. Decrease yield, forward reaction is exothermic, 2 marks. Right, next one. Going over here. How would increasing the pressure change the yield? Pressure, remember, is all to do with particles. Let's give a quick little look back here. Here we go. So we have 2 particles on the left. We have 1 particle on the right. If you increase the pressure, it of course goes to the side with the smallest particles. That's this side. So the yield increases. So yield increases. Why? There are less molecules on the right hand side. Lovely. And then finally, explain how a catalyst increases the rate. This is straight out of your definitions. It will provide an alternative reaction pathway, 1 mark, with a lower activation energy, 2 marks. Quick little reminder, here's your graph, up, down, that's the activation energy, alternative pathway with catalyst, dotty, 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 that's your catalyst, done.